Today I want us to look on integration by parts. So the first thing that you should know when it comes to integration by parts, it's the formula is uv minus the integral of v du. That's the first thing that you should know. So let's start by the example so that you may get more knowledge about it. So you've been told to integrate x sine x dx using integration by parts. So our u here will be equals to x, our du will be equals to dx, our dv will be sine x. The value of v is when we integrate dv itself, and when we integrate dv we get it negative cos x. So when we come to our equation, which is uv minus the integral of v du, we just replace it. So our u is x, our v is negative cos x, and then we subtract by the integral of negative cos x du is dx. So it's the same as negative x cos x. This negative, we bring it out here, so it becomes a positive. So when we integrate cos x, we get sine x. So the integral of cos x dx is sine x plus c. So that's our solution. So it will be negative x cos x plus sine x plus c. Let's try another one. Been told to integrate 3x e2x dx, and you integrate it by parts. So our u will be 3x, our du will be equals to 3 dx, and our dv will be e2x, and our v is the integral of e2x, which will be a half e2x. So it will be uv minus the integral of v du, whereby our u is 3x, our v is a half e2x, subtract by the integral of a half e2x, du is 3 dx. So we are first going to focus on this side that has the integral, whereby it's the integral of a half e2x. Sorry, let me make that more visible. A half e2x 3 dx. So we are going to bring the 3 out here, so we are left with a half e2x dx. When we integrate a half e2x, we are going to be left with a quarter. From the last video that I made on the integration of exponential, you can look at it, so you may have a broader understanding of integrating exponentials. So we are going to be left here with 3 over 4 e to x. So we are going to join it with the first equation that we had, plus c. So it will be, first equation will be a half 3 over 2 x e to x plus 3 over 4 e to x plus c. Our next example, so it will be integrate 3t squared e to t dt. Our u is 3t squared, our du will be 6t dt, our dv will be e to t, and our v will be a half e to t. So uv minus the integral of v du, our u is 3t squared multiplied by a half e to t, subtract by the integral of a half e to t du, whereby it's 6t dt. So as it is like that, let's take this part that we have to integrate, a half e to t 6t dt. Here we will have also to do as we did the first one, take our u and also our dv. So our u here will be equals to, let's first simplify by 2, 1 by 2, it will remain as 3, so it will be, our u will be 3t, our du will be left as 3 dt, our dv will be equals to e to t, our v will be a half e to t. So uv minus the integral of v du, so 3t multiplied by a half e to t, subtract by the integral of a half e to t 3 dt. So when we integrate this side that has the a half e to t, three dt, let me just look at it again. No, it's just 3 alone, not, doesn't have the t, like this. So when we integrate this, we remove the 3 out here, we're left with a half e to t dt, and when we integrate that, it will be left as 3 quarter 2t plus c. So we're going to join this equation with the first one that we had. We're going to join first this equation. Let me look at it. So it will be 3 over 2 te to t minus 3 over 4 e to t plus c. That's what we've gotten when we integrated by parts the second part. So we are going to join it with the first equation that we really had. So it will be 3 over 2 t squared e to t plus 3 over 2 t e to t minus 3 over 4 e to t plus c. You can go back and view that question again, because I know it's a little bit complicated. Let's go to our next example. So what you have been told, integrate x squared ln x dx. So here our u will be ln x, since ln x is given more priority over the x. So our du will be 1 over x dx, our dv will be x squared, our v will be a third x cubed. So uv minus the integral of v du will be, our v is u is ln x multiplied by the a third x cubed minus the integral of a third x cubed multiplied by 1 over x dx. So when we integrate, let me write it here, a third x multiplied by 1 over x dx. this and this cancels out, we are left with a third dx. So it will be the integral of a third dx, and when we integrate it, it will be, no, this is a third x cubed, so when we cancel out this x, it remains with x squared, so this will be x squared, and when we integrate it, it will be a third x cubed divided by the 3 that we have gotten, so it will be 1/9 x cubed. So when we join the uv that we had gotten with this, we'll find it as, it will be a third x cubed ln x minus 1/9 x cubed plus c. Let's try another example whereby we have to integrate 2 times by parts. So you've been given x squared sine x dx, and you have been told to integrate by parts. Our u will be x squared, our du will be 2x, our dv will be sine x, and our v will be negative cos x. So uv minus the integral of v du will be x squared multiplied by negative cos x, subtract by the integral of negative cos x, du is 2x. So we bring this negative out here with the 2, so it will be negative x squared cos x plus integral of cos x 2x dx. So we start by integrating this part, cos x 2x dx. So our u here will be 2x, our du will be 2 dx, our dv will be cos x, and our v will be sine x. So we just do the same, uv minus the integral of v du, whereby our u is 2x sine x minus the integral of 2 sine x. So when we integrate this, we're going to be left with, when we integrate 2 sine x, we bring this to out here, we're left with the integration of dx dx. When we integrate sine x, it will be negative cos x, so it will be negative 2 cos x plus c, and you join it with this equation, so 2x sine x, this minus and this, they multiply each other and it becomes a positive 2 cos x plus c. And this is the equation that we have gotten after integrating by parts the second part, so we are going to join it with the first part. So it will be negative x cos x plus 2x sine x plus 2 cos x plus c.